Welcome back to the Crystal Clear Electronics videos. We are now moving on with learning the IT basics with Szabolcs Pájer. Let's start programming, Szabolcs. The floor is yours.
Thank you. I would like to welcome our viewers also. When we get a task, we usually only know what the machine should do. The way the machine does this is what we have to figure out, then design and tell it. But how do we tell the machine what to do? Machines must have a so-called instruction set through which we can tell them what to do and when. The machines see the world through ones and zeros, but unfortunately we are not living in the movie Matrix to see this. How can we tell machines what to do? It is slightly more readable for the human eye if the instructions are given in text form and not with digits. One of these forms is called the assembly language, which is concise and easier for humans to understand because it uses similar English words for the instructions. It's a bit easier, but you'd still get a very long, detailed set of instructions that would be quite difficult for you to keep track of. Instead of this, we use the C programming language because in C, we can express our instructions in a much more concise and simple way. From C, our program gets converted to assembly and then to machine code. Before getting to know the C language, it's important to clarify some concepts. First, the algorithm is the solution for a task which includes the instructions to be performed in succession. Let's look at an example for this. The algorithm for making a sandwich would sound like this. Take the bread, cut a slice from it, spread butter on the bread, put salami on it, put cheese on it. You're ready. This simple example shows that the sequence of instructions makes up the algorithm, and by following certain steps, we can prepare our sandwich.
Szabolcs, I feel like there are some steps that have been missed in making the sandwich. For example, is multigrain bread good for it? Or should it be a different type? Maybe I should have unwrapped the butter, sliced the salami, and grated the cheese. This is why I don't feel that the sandwich is complete.
Yes, a valid point, but it depends on the type of programming language you are using. In the so-called declarative type programming language, it is the computer, not us, that decides how the task will be executed. Such a language is the SQL language that manages databases or even the language of human communication.
That makes sense. Actually, now that I come to think about it, I only give the taxi driver the destination and I don't tell him where to turn left and right or how to drive his car. However, my experience tells me that microcontrollers are not programmed this way.
That's right. The C programming language will be the programming language of the microcontroller. This is what we will use, in which the programmer will tell the microcontroller what instructions to execute, in what order, and in detail.
These make declarative languages much easier to use. So why don't we use them everywhere?
That's right. Declarative languages are simple to use, but at the same time, highly goal-oriented. For example, as we have already mentioned, we can only use SQL for database management. This is not appropriate for us, so we will be using the much more general C language for programming microcontrollers. The next important concept is the variable. We can store the values used in the program in variables, so we can easily find them later and refer to them. The value of a variable is not constant, as its name suggests it can change. We can read it and rewrite it. Almost every variable is of one type, which provides us with two things. One is the set of values that the variable can have, and the other is the instructions we can perform on the variable. Another important concept is syntax, which provides us with the rules of linguistic elements that we should pay attention to while programming. Fortunately, the development environments make sure that we cannot compile code with incorrect syntax, i.e. our code is compiled when the development environment, the compiler, finds it to be error-free.
Amikor a fejlesztő környezet, a fordító program hibátlannak találja azt. Elérkeztünk ahhoz a
We have arrived to the point where we can start to learn a programming language. The C language has a static type system, which means that we have to say the different types of all the variables we want to use.
egy változó létrehozásakor
So, when you create a variable, you have to say its type, its name, and then you can give it an initial value. In other words, initialize it.
értékadás nem fel.
Initialization is not mandatory. In the example, an int, integer briefly, the different types will be discussed later in detail, variable will be created called a and another with the name apple, and we will also give them an initial value. At the end of the line, we have to use a semicolon to indicate the end of an instruction. In this example, the type int is also a keyword. We can use keywords to refer to different language elements. It is worth choosing a name for the variable that refers to the purpose for which it was created.
Arra, hogy milyen célra hoztuk létre.
For example, it is advisable to create a variable which contains the length of the circle radius, such as int radius or int capital R, so we will definitely know later what it means.
Bent a benne tárolt érték.
Szabolcs, az integeren kívül milyen
Szabolcs, besides integer, what other types exist if I want to store a fractional number or another type of value?
és pontosan milyen
How can I do that, and what exactly can we store in each type?
Nézzük meg a C-nyelv alaptípusait. Az előző példában
In the previous example, we have already seen the int type. Its size is typically 32 bits on a PC, which means that its range of values spreads from -2 to the 31st power to 2 to the 31st power minus 1. Our variables are signed by default, this is also a keyword, but if we want to create them without a sign, we must put the unsigned keyword in front of the type. Then, its range of value spreads from 0 to 2 to the power of 32 minus 1. It is created like this. The integer also has a shorter 16-bit and a longer 64-bit version. The keyword to the former is short, while to the latter is long.
bira a long.
The next important type is char, which is used to store characters. This is an 8-bit variable, so its range of values can be from -128 to 127 in the case of a sign, while in the case of unsigned, from 0 to 255.
Tól egészen 255-ig. A karakter
Characters can be specified between apostrophe marks, such as this.
így. Ahogy láthattuk,
As we have seen, these types are fixed point values. For floating point arithmetic, float and double types are used. These are used for fractions. The float has an accuracy of 6 decimal places, while the double has an accuracy of 15 decimal places.
15 tizedes pontossággal rendelkezik.
Of course, the need for storing a double is accordingly higher, 64 bits, while the float type is stored at 32 bits. They are created like this.
Létrehozásuk pedig így történik. Ebben a táblázatban
The following table sums up the basic types in the C language. We have highlighted just a few elements from the table. The frequently used integer type, or int variable, is shown in the third column and requires 32 bits. We often use the double type, which has a range of values from -1.7 times 10,308 up to 1.7 times 10,308, which of course requires 64 bits, but has a precision of 15 decimal places.
308-ig terjed. Ehhez persze 64 bitre van szükségünk, ugyanakkor 15 pontosságú tizedes jegyet ad. Természetesen léteznek
Of course, there are other types, but to use them, we need to assign an external file to our program.
fájlt a programunkhoz, ilyen például a bool típus,
For example, the bool type, which contains true and false in its range of values.
magyarul ezek igazat és hamisat jelentenek.
To use them, we need to assign the stdbool.h file to our program.
Logikai változóknál
For logical variables, it is recommended to use this type.
a későbbiekben
Further on, you can find types like uint8_t.
ettől a jeltől ne ijedj.
Don't be frightened by this. It just means that it is an unsigned u equals unsigned 8-bit integer variable. In many cases, we do not need the 32-bit coverage range, only a fraction of this is enough, so we can handle our memory efficiently, which is very significant, especially in the case of a microcontroller. But what if, for example, I want to store a lot of data related to each other? Should I create a variable for each one? This would be quite inconvenient. That's why we have arrays. You can store multiple values of the same type within a single array. We need to say how many elements it can store at most to create them, such as int area 3, so our variable called area will be able to store 3 integer values. We can refer to the individual elements with their index, i.e. their serial number. The first element in our array is the element with index 0, because usually the first element in informatics has the index 0, while the third element gets the second index, as seen. We have seen how we can store characters, but it would be inconvenient for a text to be given by character. Therefore, we can easily store texts in strings. The strings resemble the arrays. Basically, the characters are stored in an array, except that the last element of the strings will always be \0, which will indicate the end of the string. We can create a string like this. We may not want to change the value of a variable, so we want to make it constant. We have the possibility, with the const keyword, we can do this when creating a variable, for example. In this case, it's important to give a value to it when creating a constant, because we cannot do that later. C compilers also have an optimization function, so, where they can, they optimize our code, simplify it, and make it more effective. We can choose the degree of optimization ourselves, or we can even turn it off. Optimization sometimes works against us. For example, after turning on optimization, a code that has worked before suddenly does not behave as expected. The compiler, and thus the optimization, only works in one file at a time. One of the easiest examples of this is that if a variable cannot be changed in a file, then the compiler replaces it with a constant, so it optimizes the code. This, in turn, results in an incorrect operation if the value of the variable can be changed in another file. In such cases, we need to indicate this to the compiler, which we can do with the volatile keyword before the variable type.
This was a very detailed presentation, thank you very much. But I'm sure the viewers are curious to know what we can do with these variables and how we can use them in programming.
Right? We can perform different operations on variables. We call them expressions, and then this set of expressions determines how the program works. Let's look at some of them. We can describe an expression by operators or operational marks. The following table shows some examples for these expressions. Let's look at the middle one. 2 times 3 plus 1. The value of the expression is 8. What does that mean? Our operands are 2, 3, and 1, and the operators are multiplication, addition, and parentheses. There are many types of operators, and between them, there is order of operations, just like in mathematics. This is called operator precedence. The following table shows the operators of the C language. We will highlight only a few elements from the table here. You can see the AND, XOR, OR operations that we saw earlier, and you can see that there is a bitwise and a logic version of them. It's important to point out that assigning values to variables can be done with the assignment operators. But don't be frightened by the variety of operators. These will become clearer as you use C. We went through the basic types of the C programming language and its operators or operations. This concludes the second video in the 10th chapter, and we will continue with the instructions of the C language, learning about branches, loops, and functions. See you again soon. Bye!